A reaction energy profile shows two peaks, with the second peak higher than the first. Which statement is correct? The first step is rate limiting. The reaction has no intermediates. The second step has the larger activation energy, or the overall reaction occurs in one step. The answer is the second step has the larger activation energy, because the height of the peak is indicative of activation energy for that particular step. The higher the peak, the greater the activation energy. The rate of a chemical reaction is best defined as the total amount of product formed, energy released during the reaction, change in concentration of a reactant or product per unit time, or the time taken for a reaction to go to completion. The answer is change in concentration of a reactant or product per unit time, because a rate of reaction refers to how quickly a reaction is occurring, which can be modeled as either reactant concentration decreasing in a given amount of time or product concentration increasing in a given amount of time. A reaction has a constant half-life and is well modeled by radioactive decay. The reaction order is most likely zero order, first order, second order, or third order. The answer is first order, because a characteristic feature of a first order reaction is that the half-life, so the time it takes for the reactant concentration to halve, is constant. A proposed mechanism is step 1, which is a slow step with A plus B going to form C, followed by step 2, which is a fast step, C plus D going to form E. Which expression correctly represents the rate law for this overall reaction? Rate equals rate constant K multiplied by concentration of A times concentration of B. Rate equals rate constant K multiplied by concentration of C multiplied by concentration of D. Rate equals rate constant K multiplied by concentration of A multiplied by concentration of B multiplied by concentration of D, or rate equals rate constant K multiplied by the concentration of E. The answer is rate equals rate constant K multiplied by the concentration of A multiplied by the concentration of B. Because C is an intermediate, so it wouldn't feature in the rate law, and D, the other reactant, is involved in the fast step, which isn't the rate determining step, and so wouldn't feature in the rate law. In surface catalysis, which process typically occurs? Reactants dissolve completely in the catalyst. Reactants form temporary bonds with the catalyst surface. Reactants bypass the transition state. Or reactants react without intermediates. The answer is reactants form temporary bonds with the catalyst surface. This causes bonds in the reactants to weaken, and the reaction can proceed via an alternative pathway with a lower activation energy. For the reaction of 2A to form 1B, if A is disappearing at 0.6 molar per second, the rate of formation of B is 0.3 molar per second, 0.6 molar per second, 1.20 molar per second, or 0.15 molar per second. The answer is 0.3 molar per second. Because the molar ratio of A to B is 2 to 1, so for every 0.6 moles of A that decrease in the reaction, 0.3 moles of B get formed. So a rate of disappearance of 0.6 molar per second of A will mean a rate of formation of B of 0.3 molar per second. Consider the mechanism A plus B going to form C in step 1, and then C plus D going to form E in step 2. Which species is an intermediate? A, B, C, or E? The answer is C, because it is produced in the first step of the mechanism, however, is then consumed in the second step, meaning it doesn't appear in the overall reaction equation and isn't a reactant or a product. A plot of reactant concentration A versus time t is linear with a negative slope. This is most consistent with a first-order reaction, second-order reaction, zero-order reaction, or a reaction with no rate constant. The answer is zero-order reaction, because the rate at which the concentration of reactant is decreasing is constant, meaning its decrease in concentration has no impact on the rate of reaction, meaning zero order with respect to concentration of A. Which species is classified as a reaction intermediate? A species present only at the start of the reaction, a species added to speed up the reaction, a species produced in one step and consumed in a later step, or a species with the highest activation energy. The answer is a species produced in one step and consumed in a later step, because intermediates get formed during a reaction, but they get used up before the end, meaning they don't appear in the overall reaction equation. A multi-step reaction has 3 elementary steps. How many intermediates does the reaction have? 1, 2, 3, or 4? The answer is 2. For the rate law, rate equals rate constant K multiplied by concentration of A to the power 2 times concentration of B. The reaction is first order overall, second order overall, third order overall, or zero order overall. The answer is third order overall, because the reaction is second order with respect to A, because A is raised to the power 2 in the rate law, and the reaction is first order with respect to B, because B has a power 1 in the expression. This means 2 plus 1 equals 3 overall, third order overall. On a reaction energy profile diagram, the highest point on the curve represents the products, reactants, transition state, or catalyst. The answer is the transition state. Which collision is least likely to represent an elementary step? A plus B going to form products, A going to form products, A plus B plus C going to form products, or A plus A going to form products. The answer is A plus B plus C going to form products, because this would be a collision that would involve 3 particles, a termolecular step. This is highly unlikely, as it involves 3 particles having to collide with sufficient energy and orientation at the same time. Which mechanism best illustrates acid-base catalysis? A metal surface adsorbing a gas molecule, a reactant gaining or losing a proton during the mechanism, a catalyst increase in temperature, or a catalyst lowering collision frequency. The answer is a reactant gaining or losing a proton during the mechanism, because acid-base catalysis involves the transfer of a proton or H plus ion during the reaction. A multi-step reaction has 2 elementary steps. Which feature must appear on its reaction energy profile? 2 activation energy peaks, 1 intermediate energy minimum, equal activation energies for both steps, or 1 transition state. The answer is 2 activation energy peaks, 1 for each elementary step, with each peak referring to a different transition state.